So I want to show you guys today how this factoring by grouping that we've done the last 2 days actually works as part of a bigger process. This is how we're going to factor all of our trinomials. I am, however, going to show you a shortcut on factoring what I'm calling a simple trinomial. And you'll see the difference once we get into it. So what I'm calling a simple trinomial is one that starts out just with an x squared term, right? There's no like 3x squared at the beginning. So, and this isn't what they're called, but just for the sake of what we're doing, it's what I'm going to call them. So like x squared plus 5x plus 6, I'm calling that a simple trinomial, where something like 3x squared like this, I wouldn't call simple just because of the number out front. So just keep that in mind. Simple, just an x squared at the beginning. So we're going to spend a couple of days doing the simple ones because I want to show you kind of the long way to do it. And then hopefully you'll see a shortcut that you can take. If you don't see it, I will explain it. So let's go back and talk about multiplying these things together just real quick. So I'm going to multiply this. I'm going to distribute the x to x plus 8. And there's a reason I'm doing it kind of the long way. And then I'm going to distribute my 4 to the x plus 8. Okay, so I took each piece in the first one and multiplied it by the second binomial. And then I'm going to distribute these individually. So I've got an x squared, an 8x, and then a 4x, and a 32. And if I did this right, the two terms in the middle are going to create a combined middle term and a 12. Okay, so 32 on the end. So basically, factoring a trinomial is taking this process from the bottom and backing it up to the beginning where you have the two binomials being multiplied together. Now, it's not hard, but the first step is actually kind of the tricky one. Once you get past that first step, it's factoring by grouping like we've done for the last 2 days. So that's why we spent that much time on it, because I think it's really important to kind of understand the rest of the process. That way you can focus your attention and energy on the first step. All right, so here's how we do this. We are going to take the middle term and we are going to split it up into two numbers that multiply together to give us the last term. Okay, so I want to split my 13 up into two numbers, but specifically two numbers that multiply to 30. Okay, so I can't just split it up into like 5 and 6. Oh, that's 11 anyway. I can't split up into like 6 and 7, right? Because 6 times 7 isn't 30. So the two numbers that I come up with to fill in these blanks right here need to multiply to 30 while they add to 13. Now, there's a reason I picked this one, because I think it's pretty obvious that it's 3 and 10. Okay, 3 plus 10 is 13. 3 times 10 is 30. So we need numbers that add to the middle and also multiply to the end. Okay, those are the two important numbers. Add to the middle, multiply to the end. So once I've split that 13, everything else just drops down. Right, the n squared drops down, the 30 drops down, and then you go back to factoring by grouping that we've done the last couple of days. So I'm going to cut this thing in half. Greatest common divisor on the left is n, which leaves me n plus 3. And on the right, my greatest common factor is 10, which leaves me, again, n plus 3. So this polynomial, this trinomial, factors down to n plus 3, n plus 10. Okay, you can multiply it back out and see if you multiply it back out in combined terms, you're right back up to the top. The tricky part is splitting that middle number. You have to split this addition-wise. You want to split it into two things that multiply to the guy on the end, 8. Okay, so we can't do 8 and 1, right? 8 plus 1 is 9. It's not 6. I have to come up with the right pair of numbers that add to the middle term, and multiply to the end term. So basically what we're doing is we're ignoring this out here for right now. And we're ignoring it because it's a 1. Once we start doing some of these polynomials that have a coefficient out front, it's a little bit bigger process. It's not harder. It's the same math. It's just it's an extra. They're literally bigger numbers. So I'm going to split this up into 4v plus 2v, and then I'm going to drop down my 8 and my v squared. Now, if you reverse this and in the middle you put 2v plus 4v, it's fine. It's going to work out exactly the same at the very end. So if you're comparing your work to somebody else's and you see some differences between your problem, it's the final bottom that we're looking at. And what are your actual factors? So when I split this guy, v at the front, so leaves me v plus 4. In the back half, I've got a 2, which leaves me again v plus 4. So this guy factors into v plus 2, v plus 4. Okay, it takes a little practice. And again, I mentioned you might see a shortcut on these. Now would be a time to kind of start looking at the process and seeing if you can come up with a shortcut on how to jump from the problem to the answer. I will explicitly tell you that shortcut probably tomorrow. I want you guys to get some practice doing this the long way, I guess, before I show you a shortcut. So I need numbers that add to 10 and multiply to 9. Add to 10 and multiply to 9. So my v squared and my 9 are going to stay there. That 10 is going to split into 9 plus 1. All right, add to 10, multiply to 9. So when I do the greatest common factor on the left here, v plus 9. And on the right, 1, v plus 9. All right, so your factors down at the bottom, v plus 1 is one factor, and the v plus 9 is the other factor. Okay, I'm trying to keep everything really straightforward. I'm focusing on positive numbers, so you don't have to worry about messing around with negatives and how that throws off the addition part in the middle. All right, last one. Two numbers that add to 16 but multiply to 63. So you can't just pick anything that adds to 16. 8 plus 8, right? 8 plus 8 doesn't multiply to 63. So you need to kind of focus on the 63 and come up with numbers that multiply to 63 and then check to find the pair that adds to 16. So I'm looking for numbers that multiply to 63. If you need to, make a list. Come up with numbers that multiply to 63. I know that 9 and 7 are going to work for me. And again, it doesn't matter which one you put first. You could do 9x and 7x on there. All right, greatest common factor is x. And on the right, greatest common factor is 7. Okay, this guy factors x plus 9, x plus 7, or that order doesn't matter either. All right, as long as it's x plus 9, x plus 7, it doesn't matter which one comes first. Okay, your homework, everything's positive. Okay, everything's positive. Focus on coming up with the numbers that add to the middle and multiply to the last number.